Hey everyone, my name is Joris Peels, and this edition of 3D Printing News Unpeeled will see us talk about a new Arkema material, macro MEMS, and new 3D printed saddle. So first on, let's talk about that 3D printing material. So this is good because, there's an Arkema material. It's called HP3D HRPA12S. Now, the reason this is good is because it's new MJF material that brings us a lower cost per part, and lower cost per part is a key thing. We all know that 3D printing materials are overpriced. It's either because there's, the industry is quite fragmented, the volumes are quite low, considering the polymer industries and the volumes they're used to. Um, Everyone's used to having a high margin business, so it's difficult to wean yourself off of that high margin, nice money that you're getting per kilo. And, it's kind of a chicken and the egg story. So if we reduce the cost per part, then we may make more 3D printing implementations possible. If we reduce cost per part, we make more um, business cases possible. We make more things make sense in 3D printing. So this is why I think it's wonderful. And so far, a lot of people have just been saying, "Hey, now we have PEC or carbon fiber PEC, or we have purple day glow PLA," and you know that's been going on a lot in the material side of things. But what makes me much more excited is things like, this is a material eminently suited for rail, and it matches the rail interiors of Deutsche Bahn. And that would mean that we can now access this rail refurbishment market, or something that actually has value. Yes, it's nice to have a strong material, or it's nice to have that polycarbonate variant that everyone's used to using from Covestra or whatever. But I think what's much more important is if we just look at improving the technology in and of itself and saying, hey, look, it used to be that this glass would cost you $5, and now with this material we can make it $4. So I like that very much. I think that really would go a long way to solving our problems. Now, this material may lead to a cost per part reduction of a quarter in total. So that could be really significant for a lot of cases. And the part of the reason is that the reusability ratio is 85%, which also makes this much more sustainable because you end up throwing away less powder. The HP has tested this with Decathlon, Erpro, Materialise, other companies, and I think this is wonderful. I think that we need to see more of this, more people reducing costs and stuff like that. Now, what's also said is this has a better surface finish, which may allow you to do a lot of parts better, from just off the machine without having to post process anything. So that could also further reduce costs to having end use parts. So, I think this is a great development, wonderful development, and wanted to point that out to you. The next thing is it's a new 3D printed saddle. 3D printed bike saddles have become quite the success story. Most of them are by carbon. They're made for Selle Italia, specialized and other kind of materials, but more and more people are getting into this game. And this saddle is the Prologo Nago R4 Pas 3D MSS saddle, which is a super lightweight saddle which combines like a carbon fiber kind of body, another carbon or polymer reinforced plastic components with a 3D printed saddle with tri-zones. So there's three different zones that are different depending on where they are on the saddle. You can see that in the illustration in front of you. And they have different infill kind of structures, different lattice type structure. In this case, it's a Voronoi, the beloved Voronoi, or a tetrahedral structure to give you different types of support depending where on the saddle you are. And that's a lot of logic. I think also if you've used one of these saddles, you test them, you know that it seems to be a bit cooler. It's a little bit less of a profile. They may be less plush than other saddles, but I can imagine on a long ride that this could be a real advantage. The wonderful thing is this thing is apparently going to retail for 420 euros. So that's around, like, I don't know, I think it's about the same in dollars, 440 or something in dollars, something like that. That's quite. I bought bicycles for that amount of money. I'm pretty good. I bought a secondhand Trek mountain bike for that amount of money at one point. So that's a lot of money for a saddle. So it's super profitable. If you look at the rest of the components of this thing, if you look at what this component would cost in additive manufacturing, this is a very profitable thing, and it seems to be growing. There may be more opportunities as well. If you look at what Carbon has been doing for these backpack kind of zonal supports that are in the backpack, that's a very similar type of structure. And there are probably some safety concerns, but we can also imagine doing this for car seats and racing car seats and all sorts of other types of seating type of things as well. So And then further in bicycles, we could expect to do a ton of stuff in bicycles as well. So I think, yes, another success story, we continuation of the success, and it's it's something that we would expect to see grow, much more, than beyond. And yeah, if people keep buying these things for $420, like, it's going to be like an amazingly profitable thing for everyone concerned. For Carbon, for the company doing the 3D printing, we don't know who that is in this case. We don't even know if it's Carbon, by the way, which is a guess, and also for Prologo and its owner. So yeah, I think it's a really very profitable business case. So here you see a close-up shot of the saddle. I don't know if you know what that is. Just looking at it, I don't know what it looks like exactly. It looks like it could be a different type of material, but I'm not 100% sure what it is, and they don't really go into detail so far, at least. But I'll update you if I find out what this is. It would be interesting because this has basically been kind of Carbon's bailiwick so far, and it would be interesting to see more Henkel and more other people get involved, maybe even on MGF and other kind of materials, maybe even FDM and other types of materials as well. But so far, yeah, it's basically Carbon's little playground, and they have it basically to themselves. So, let's see if they get some competition there. The next thing is macro MEMS. So this is something I've talked about in an article. I'm not sure, a couple months ago, a couple years ago, and that was the idea, the concept at the time that MEMS, which has, you have to have a lot of volume to warrant investing in MEMS. But once you make a MEMS kind of production setup, you can make millions of components like accelerometers and other kind of sensors and things very, very inexpensively. But then what I thought of doing, I thought of at the time was like, wait a minute, guys, what if we only need 100 of something or 1,000 of something? What if we do this macro MEMS? So we do much larger MEMS, so it's not as tiny, it's not as intricate, maybe. It's not as huge. If we're never going to make a million of them, but it's like a smaller production run, but maybe it's a bigger device, but it does perform more or less the same thing. And this is an example of this. So I'm really just super happy with this. This is a paper in Nature, a 3D printed micro hemispherical shell resonator with electrostatic tuning for Coriolis vibratory telescope. It's a paper by Buoying Hou, Ye Chaofan He, and Weidong Wang. And what they're doing is they're making something called a microhemispherical resonant gyroscope, a Coriolis vibrating gyroscope. I have no idea what this is. It doesn't matter for the story, at least. But usually this is done by MEMS, and the MEMS is a wonderful way of making this. But there's about 12 different steps. There's a lot of conveyance and a lot of stuff going on, which makes it not very cost effective. So now what they've done is they use Pew or projection microstereothography to make these precise components. Now, apparently in this gyroscope construction, there's a kind of an air gap that needs to be in there for the gyroscope to work. And that air gap is a real thing that is really difficult to make with MEMS and relatively easy to make in far fewer steps, 2 steps in this case, with a PU or PMSLA or projection microstereolithography, whatever you want to call it, this week. So this is very, very promising. The 3D print job was done on a Boston Micro Fabrication Micro S130, which is a relatively affordable lab kind of type machine. And that would mean that you could take that BMF printer and go to production with it, at least in limited form. So, you know, are we a danger to MEMS? No, of course not. The MEMS methodologies are great for making 10 million or 100 million or something, and that's never really going to make that much sense with 3D printing because for a really long time, and even maybe never ever would make sense 3D printing. But if we need a smaller volume of something, if we need a quicker production volume of something, and if we need that startup cost, that startup time is really critical, we can make a macro MEMS. So we can make a MEMS type device, which maybe is bigger, maybe is more inefficient, uh, but would be much easier to get the first 1,000 of. Now, what's really cool about this is that this has electrostatic tuning. So you can tune the properties of the 3D print. You can change them to change the properties of this final gyroscope device. Now, that is something very spectacular in the 3D printing course. We're really amazing at making these properties and going really quickly from idea to a file or a setting to change it. So, I don't know how important this is for gyroscopes because I know nothing about gyroscopes. But think of more kind of scientific or optomechanical devices where this tuning property, the ability to change it very quickly, would change its ability to handle certain frequencies or something like that. And then we can have a real winner on our hands in a lot more applications. Now, again, I don't know what the demand is out there, but I could imagine that there could be considerable demand behind this. Like My example for this is always like, let's say you're making a fire truck and you want a pressure sensor for your fire truck tires, for example. I can imagine that could be really important for a fire truck. You don't want that thing to, there's a big giant thing going at a big speed. So you don't want that thing, the tire to blow out. That could be disastrous, right? So you might want a much better tire sensor that you can get in the market today. You might need it specifically for the fire truck and specifically for that model. Now that doesn't make sense with MEMS. You just can't get that kind of functionality with something that has a really low volume because there's not that many fire trucks in the world, um, and not that many from that one tire or regular manufacturer. But if we could just make a sensor with 3D printing using micro SLA or other technologies, then we can make a low volume production run where the engineering cost would be considerable, maybe, but then the actual cost per part would be really, really low. So I think I love this, and I think we'll see more and more of this happening as time goes by. My name is Joris Peels. This was another version of 3D Printing News Unpeeled, and I hope you found this very, very useful. You have a great day.